Welcome back to Database Internals Crashcasts. I'm Sheila, and as always, I'm joined by the database wizard himself, Victor. Before we dive in, I just want to remind our wonderful listeners that if you're enjoying the show, please rate us on your favorite podcast platform. It really helps us reach more database enthusiasts like you.
Thanks, Sheila. And hello, everyone. Today we're wrapping up our Introduction to Databases season with a comprehensive summary. We've covered a lot of ground, from the basics to some pretty complex concepts, so this episode is going to be a great refresher.
Absolutely, Victor. And to kick things off, I've got a quiz question for our listeners. Are you ready?
I'm always ready for a good database quiz. Let's hear it.
All right, here goes. In database terms, what does ACID stand for, and why is it important?
Ooh, that's a great question, Sheila. It touches on a fundamental concept in database management. I'm sure our listeners who've been following along will have some ideas. It's not just about knowing the acronym, but understanding why it's crucial in database operations.
Exactly, Victor. We'll reveal the answer at the end of the episode, so stay tuned, everyone. Now, let's start our summary journey. Victor, can you remind us what exactly a database is?
Certainly. At its core, a database is an organized collection of data stored and accessed electronically. Think of it as a digital filing cabinet, but way more powerful and efficient. Databases allow us to store, retrieve, and manage large amounts of information quickly and accurately.
That's a great analogy, Victor. So, if I understand correctly, instead of rifling through countless paper files, a database lets us find what we need with just a few keystrokes.
Precisely. And not only that, but databases also ensure data integrity, allow multiple users to access information simultaneously, and provide ways to analyze and manipulate data that would be impossible with physical files.
Fascinating. We also talked about different types of databases. Could you give us a quick overview?
Of course, the main types we covered were relational databases, which organize data into tables with rows and columns, like SQL databases. SQL, or Structured Query Language, is used to manage and query these databases. Then there are non-relational or NoSQL databases, which use different data models like document, key value, wide column, or graph. Each type has its strengths and is suited for different use cases.
That's helpful. And we also discussed something called database models. Right. How do they relate to these types?
Great question. Database models are essentially the theoretical foundation for database types. We discussed several models, including the hierarchical model, which organizes data in a tree-like structure, the network model, which allows more complex relationships, and the relational model, which is the basis for SQL databases.
That makes sense. And if I recall correctly, the relational model is the most widely used today, right?
You've got a good memory, Sheila. Yes, the relational model, introduced by E.F. Codd in 1970, revolutionized database management and is still dominant. However, with the rise of big data and need for scalability, NoSQL models, which stands for not only SQL, have gained significant popularity in recent years.
Speaking of architecture, we also covered different database architectures. Can you refresh our memory on that?
Certainly, we discussed several architectures, from single-tier where everything is on one system, to multi-tier architectures that separate functions like data storage, application processing, and user interface. The client-server model, where a centralized server manages the database and clients request data, is particularly common.
That's right. And I remember we talked about something called data modeling. How does that fit into all of this?
Data modeling is a crucial step in database design. It's the process of creating a conceptual representation of data objects and their relationships. We covered entity relationship, ER modeling, which uses entities, attributes, and relationships to describe the structure of a database.
Oh, I remember those ER diagrams. They looked a bit like a complex family tree to me.
That's a great analogy, Sheila. ER diagrams do resemble family trees in a way. They show how different entities, like family members, relate to each other. It's a visual way to understand and design database structures before actually implementing them.
This has been such an informative season, Victor. Before we wrap up, what would you say are the key takeaways for our listeners?
Great question, Sheila. I'd say the key points are: Point 1. Databases are essential for organizing and managing large amounts of data efficiently. Point 2. There are various types of databases, each suited for different needs. 3. The choice of database model and architecture can significantly impact performance and scalability. Point 4. Proper data modeling is crucial for creating effective and efficient databases. Point 5. Understanding these fundamentals is key to working with any database system.
Excellent summary, Victor. Now, I think it's time to reveal the answer to our quiz question. Can you do the honors?
Of course. The question was about ACID in database terms. ACID stands for atomicity, consistency, isolation, and durability. It's a set of properties that guarantee reliable processing of database transactions. Atomicity ensures that all parts of a transaction complete or none do. Consistency maintains the database in a valid state. Isolation ensures concurrent transactions don't interfere with each other. And durability guarantees that completed transactions persist, even in case of system failures.
Thank you, Victor. And thank you to all our listeners for joining us on this journey through the fundamentals of databases. We hope you've enjoyed and learned from this season as much as we have.
Absolutely, Sheila. And remember, everyone, this is just the beginning. There's so much more to explore in the world of databases.
Indeed, and we'd love to hear from you. Visit crashcasts.com to learn more, join our Discord community to discuss database topics, or support us on Patreon if you'd like to help us keep producing these episodes. Don't forget to subscribe and rate us on your favorite podcast platform. Until next time, keep your queries optimized and your data integrity high.